Just what in the world have we got going on here? So what we got here today is a transmission control module out of a 2015 Nissan Murano. I diagnosed this thing a few days ago and we got a new module, threw it in there, fixed the problem. I wish I could have filmed it, but I actually forgot my camera stuff at home that day, so I thought it'd be pretty cool to take this transmission module apart and see if we can just find the fault. And I know I've got one of these in my pile of scrap over here that we might can salvage parts for and actually fix this thing just for the fun of it. So here is the label and everything of what was in the car, and we've got a used one put back in there, got it programmed and everything for them. And the problem they were having was this code right here, P0744 TCC solenoid circuit. And what I've got here laid out is basically all the valves that this TCM would be commanding. As you can see, we've got 3 of them on right now, 2 of them off. This one here is the output for the TCC solenoid, and this is the output for, I think they call it selector. Let me see, I got it pulled up here. Yeah, select solenoid valve, that one right there, and then torque converter clutch solenoid is the one we have a code for. So we don't have a code for this one right here currently. You see, we only have the 744, but this bulb is out. I want to show you why these are on and kind of how this does a circuit check when you first turn it on. And for that, we're going to be using the Pico. So these are actually on right now. So I've got all these on the circuit. They all share a ground basically outside of the TCM. So there's power coming out of the TCM to these, and that's why these are on. But there is a circuit check being performed pretty much all the time, or at least with key on. So if I touch the output right here on the Pico, you can see that we've got a pulse width duty cycle going on. And if I turn the ignition off on the go diag box over here, you can control battery output and ignition output. So let's take and go back on this lead right here, and we're going to turn the ignition on. Okay, so you've seen at the very start there we had a slightly different pulse width. This section right here is basically a circuit check. Now this bulb right here, this bulb never come on, or at least I didn't see it. So let's do this again on this one here. This is our select. Okay, so turn the ignition off, back on. There you go. You've seen that on the Pico there, we had a signal coming out of the TCM through the bulb, and it's basically circuit checking to see if the circuit can draw current. If it can draw current, then it knows that this circuit's complete. This one, however, let's do, we're key on right now, and this is our TCC circuit. We have nothing on the scope. We power this off and back on. You see, we never get that duty cycle to check this circuit here. So that's how I determined that the module itself was bad in the car. I never got any kind of output. Nissan, in their infinite wisdom, under actuation test here, we can't actually control anything. We can't command any of these circuits on. We can't do anything. Even under like special functions, all of this stuff is like not pertaining to any kind of controls. We have no output controls. Work supports, same thing. Nothing here that will let us command this TCM to turn a circuit on to check it. If these OEs would just give us some more controls, things like diagnosing this would be breeze, be so easy. They don't want that, especially Nissan. They don't want to make diagnosing easy. They want it to be hard for you. I don't know why. But that proved to me the TCM was bad, and of course I did my due diligence on the vehicle, checked my circuit, make sure there was no shorts to ground or anything like that. They had actually replaced the valve body for this code, and for all I know, the solenoid might have been shorted and it might have killed this driver. I do not know. All they know is they put a valve body in it and still the same issue. So that's when they called me. So let's see if we can trace this circuit on the board, figure out where it goes, and figure out what's bad. I've kind of forgotten where I was at. I had to run home to get an SD card for my little microscope here so I could record using it, looking at the board. And while I was there, I had a package show up. The new Topdon Ultra Diag. Yeah, so I went ahead and hooked it up and did the same thing. And I did notice that this does come on when the key is first turned on. And we still get the same codes with the Ultra Diag. So looking forward to trying this thing out and seeing how well it works. If you don't know, the Ultra Diag uses Topdon designed diagnostic software. So they have started developing their own software, and if you've got one of the Topdon, I think they call it Top Scans, it's a little tiny dongle like this one. It's really cheap. It's on my Amazon store. I've had one for probably a year now that they sent me for beta testing, and all the beta testing has basically led to this tool getting its own software, and I'm looking forward to trying it out. But getting back to this thing, we know that this was our circuit that doesn't work, so we know which pin it is on the TCM. So we're going to put this under the microscope here and trace this circuit to find out where it either loses connection or figure out what controls it, and then figure out if that controller is working or not. Alright, so going by our diagram, we need pin 38. So I've just got my terminated lead in here, and this is just connected to my meter. I've got it set on diode mode, so when it sees a connection, we'll get a beep. If I can use my hands here. So you can see that, like if we're on the wrong pin, nothing. When we get to the right one, get a beep. So basically we're just going to be tracing the board, listening for beeps, and I kind of just always like to start on the easy side of the board, looking to see if it's possibly something easy to trace on the back side. So get to our correct pin here, which is right here. Alright, get you in focus a little bit, and as we can see, this doesn't have any connection to this side of the board directly. So our start of the connection is going to be on this side of the board, and what I usually do is I just kind of look in under the edge of the connectors. I know y'all ain't going to be able to see that too well, but let's see if I can get you in just a little bit better here. We are looking for let's see, terminals should be over here on this side somewhere. Alright, so that one right there. So I'll just follow the trace out. So let's go back under the microscope here. Alright, so get this in focus a little bit. I think it was this one. Yep. So we see this trace comes out here. So if we touch this capacitor here, same thing, and we can see it jumps back through the board. Okay, so let's flip it back over. So back on this other side, we're going to be looking for where that jumps through the board. So if we just kind of pick here, we got connection there, and see how that like makes one beep but goes away? That means there's some kind of diode in that circuit. So that's not what we want. We want a continuous beep like that. So we need to then follow this trace around the board until we get to wherever it goes. And we're jumping back through the board over here. So we can see like we've got these huge pad with all these pass-throughs, okay? And we've got a lot of these circuits here hitting pass-throughs, and that's the one we want right there. So we need to see where this goes on the other side. And on the camera here, you can see it's going to be under that chip right there. A little trick that I use sometimes is I'll use a little thin piece of wire if I'm having a hard time figuring out where something is. I'll use this little tiny wire. Yep, real thin wire. And you can sometimes poke this through these pass-throughs and see where it comes out on the other side. But on the other side of this, I'm blocked. It won't actually go through that. So like, show you what I'm talking about. Let's go over here to one of these others. So this hole, it went through that, okay? And if I flip the board over, I now have the wire coming through, and I know exactly where that's coming through the board. But the hole that I need right here is, yeah, it's blocked by the chip. So we know it comes under this chip somehow. So it's going to make a lot of sense that it connects to that chip. So let's get back under the microscope here. Get my wire back on there. So under this chip, it's going to be coming out and quite possibly making connection here with one of these. So let's just check a few of these. So no beep, no beep, beep. Okay, so this circuit right here. So this is where those are going, and this is also coming over here to some kind of diode, I'm guessing. Yep. See how we lost our beep? That's a diode, okay? And same thing there. Now, this circuit, I'm not real sure why it's coming out here, but chances are it's probably going somewhere for the main MCU chip over here to actually sample this circuit with and check to make sure it's actually outputting like it should. So we can actually trace this probably back to the MCU as well. So we've got this one pass through that's got a solder ball in it, and if we take our piece of wire and we put in here right next to that solder ball, flip this over, so that solder ball actually does not pass through. Let's see, let me get back under the microscope here. It should have been right here. So that one doesn't pass through all the way. That makes it very hard to figure out where that goes. So let's see. This could be our sample wire also, wherever it goes. It's all going to be going over here. Let's hook my connection back up to the pin here, and if we touch these we get solid connection. So if we just follow this around, we know it's going to be in one of these traces. Okay, and so if we follow these traces on around, they do get some of these pass-throughs. So we just find one that gives us a good solid beep, we'll know we're on the right path. So none of those. So over here we're getting them split a little bit. And not having much luck finding it. There we go. So that one right there is a solid connection all the way around. Okay, let's take my wire. Let me double check, make sure I'm on the right one. And I've lost it. Oh, because my wire come out of the plug over here. My wires are getting a little worn out. My female plugs are a little loose. So, okay, that one right there. Let's see if we can stick our wire through the hole here. Yep, goes all the way through. And you can see where our wire comes up, and we've got probably a little diode or maybe a little resistor right here. Yep, that's going to be a big resistor, I believe. Let's switch our meter to ohms. Ohm meter is saying 250 thousandths. So this resistor is basically going to be just putting some resistance in the circuit there for the MCU to be able to read, no problem, without it messing it up. So I bet we keep tracing this around. There we go. There's where the MCU is sampling. That pin right there. So Now we know the MCU samples that circuit. Get back on that right there. And yeah, the MCU is just sampling it there. It's basically, that's how it's knowing to set the code. We need to verify that that chip is sending out a signal or able to control it. I'm going to bet it probably is a bad chip. I'll need to figure out the data sheet on it and kind of look up the inputs, outputs, controls, stuff like that for that thing. Well, unfortunately, our board here, the donor one that I have, yeah, they're not the same. I thought this would still have the same driver chips on it, but clearly it doesn't. So back in the scrap pile that goes, where this will eventually go. But for an experiment, how about we do this? We've traced this issue, or at least the circuit, down to this chip. I can't find a data sheet for this because the numbers that are on this, they don't actually cross anything, so those are probably what they call like a mask number. But we do have two others here that are the same. They're all the same numbers on them. So how about we just take this one off and swap it with one of these other ones and see if our code clears and something else doesn't work. Or maybe we get lucky and, like, if we swap it with this one, that circuit's not used, even though you can see the outputs there. But I mean, we've got like maybe a 1 in 6 shot, because just by looking at this. Okay, let me get you guys zoomed in here a little bit better. Where's something I can point with? So if we just logically look at these, they're all bonded to the board here. So let's say this top trace here is 12 volt power. These are going to be switching 12 volt power and sending it out. Okay. We can see that we've got kind of the same output here, 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 there. You can see how all these outputs are the same. The only one that's kind of different is this one here is not got the capacitors in here. So I feel like this one is going to be the one that's unused. So if we swap this chip, which we think's got the bad one here, with one of these other chips, that circuit's going to then reset a code for a different solenoid. If we really wanted to and get crazy with it, we could probably unsolder all of these and put jumpers from here to the pads over here, and maybe figure out where the inputs is that control this and move the inputs over here as well. But that's a pretty extreme thing. I guess if you're in a real bad pinch, can't get one of these things, you could do that. But we're just doing some experiments, so I think I'm just going to take the hot air station and move that chip over, swap it with another one, and we'll hook all of our lights and everything back up and see if we clear that code, but set a new code. So using the hot air, I got it off, but as you can see, I did pull 2 pads with it, but luckily on the board, those pads don't actually go to anything. And you can see right here, this is actually where our circuit was coming up through the board. So they actually went to these 2 pins but then somehow they were connected to that inside the chip there. Well, I got everything back together. I switched basically these two with each other, and I'm a little stumped because we're not setting any codes other than range switch. Of course, I don't have a range switch hooked up, and will also come with ECM, obviously. But we did get rid of the TCC code, the solenoid code, but we still only have the 3 lights here, and this one will still, if I cycle the ignition off and back on, you can see it still comes on, but the torque converter solenoid circuit, it still never does anything. Even on the scope, you can see the little bit of noise there. If I turn it off here, you see it goes away, and whenever I turn it back on, there's no circuit check there. So I'm now wondering if the circuit check is actually for it to see a path to ground versus current. That's the only logical thing I can think. And since Nissan doesn't let us turn on solenoids, I can't now test the outputs. But I have a feeling that it's happy now. I don't really understand. Maybe I just got real lucky in that section of the chip when I swapped it. Either it went to another part that wasn't used, or maybe there wasn't nothing wrong with the chip at all, and maybe, just maybe, it was a solder connection, possibly. And, or maybe could possibly be a connection in the chip itself, and heating the chip up to take it off might have temporarily made a connection again. I'm not real sure. But either way, the code is now cleared. That was a hard fault, which is no longer there. So it is this gray wire here. Let's turn this ignition off here. And let's unplug the gray wire. Okay. Let's go back out of here. So let's turn ignition back on. Everything lights up. Let's see if we get our torque converter code now. Let's go back into the transmission. Read codes, and there we go. PO740 torque converter. It was a 744, now it's a 740. It's pretty interesting, but I think we somehow temporarily fixed this circuit board. Now I'm never going to use this thing. It'll be for parts. But it's still pretty interesting. So, what do you think, guys? Do you like this kind of stuff? I do. I wish I could get more of it. I like doing board work stuff. I like trying to figure them out. I really wish I could have found the data sheet to this thing, to that chip. If I could have actually checked inputs versus outputs, and also possibly even triggered the input some way to see if we got an output. But these manufacturers like to not give us the real chip number or something like that, so keep everything kind of secretive for us. But either way, still pretty cool. I guess I could have done a little more, like just work with it, like how it's powered on here, which actually all my bulbs have went out for some reason. Did I unplug my ground by accident? Nope, it is still on. For some reason it just turned everything off, but whatever. But it'd be real cool if I could have just like went through one of these chips and actually tested 4 inputs if I could turn them on and off with the scan tool. I could turn this output on, and I could look for output or inputs here and relate that to the outputs there. But like I said, that's going to rely on them giving us a little bit of control. Nissan doesn't, because they're terrible. But anyway, that's it. Thanks for watching, everybody. We'll see you guys later.